Hey everyone, in this video we'll be solving this problem from the handouts of Jaan Kalda. It's from the kinematics section. And so basically the problem is very simple. So we have two rings whose radius is equal and it is equal to r. And the distance between their centers is a. And the ring on the left is moving towards the right with a velocity v. And the ring on the right is at rest. So we have to find the velocity of this point of intersection. So try this problem out for a few minutes and then come back for the solution. So beginning with the solution, so we have these two rings. So let's say this ring is moving towards the right with the velocity v. Distance between their centers is a. So we have to find the velocity of this point p. So what the obvious way of doing this problem is take this point O as the origin, write the coordinates of point P relative to this point O, and then differentiate that point, right? Because differentiating the position vector will give you the velocity. But we are going to be taking advantage of symmetry in this case. So let's say there is a reference frame that is moving towards the right with a velocity of v by 2. So if we write the velocity of these two rings relative to this reference frame, what we'll observe is this left ring moving towards the right with a velocity of v by 2 and the right ring moving towards the left with a velocity of v by 2, right? So now the utility in doing this is that now the thing is this point P will have no velocity along the x direction because the x coordinate of this point P is not changing, right? If we take this to be the origin. So this point P will only have a vertical velocity now because of symmetry, which means the x velocity of the point P relative to this reference frame, let's say R, is 0. So now in order to find the velocity of x relative to ground frame, we just have to add the velocity of the reference frame vectorially. So this will be v by 2 I cap. Now the thing is, let's just go back to ground frame. So this is moving towards the right with v. So after a while, let's say the ring is now at this position. Now, as you can see, this is where the point of intersection is. So basically this point of intersection will only move along the circumference of this ring, right? So we can actually write the net velocity of point P to be tangential to this ring. Let's say its velocity is u. We determine the x velocity to be v by 2. So if we find out the y velocity, which let's say it is vy, then the problem is done. So for that, if we join the point P and O together, and if we drop a perpendicular, we can see these two are similar triangles now. So if I say this angle is theta, then we can say this angle is theta as well. So now just write cosec theta. Now, if we write cosec theta from the upper triangle, I'll get it as u divided by v by 2. And if I write cosec theta from this triangle, it will be, as this is r, this distance is r by a by 2. So this distance is going to be square root of r square minus a squared by 4. So the cosec theta from the bottom triangle is going to be r divided by square root of r square minus a square by 4. So the final speed of the projection point of intersection. So the final speed of the point of intersection will be v by 2 square root of 1 minus a square by 4 r square. So this is the speed. You can also determine the velocity by finding vy as well. So that was it for this problem, guys. If you enjoyed, please like and subscribe, and thanks for watching.